I have quickly modelled the basic robot moving parts in Solidworks and put them into an assembly. Before we can import the solids into MD, we need to set up some coordinate systems so that MechDesigner will put the parts in the correct position and orientation. The robot mechanism is built on the front plane in MechDesigner, so I will map the front plane in MechDesigner to the front plane in the assembly in Solidworks by making sure that all the coordinate systems I define in Solidworks are built onto the same front plane in Solidworks. I'll show you what I mean. Let's start with the frame. Open the frame part in Solidworks and define a plane offset from the front plane and call it MD front. Now we need to edit the plane offset until it is coplanar with the assembly front plane. MD plane maps to the front plane in MechDesigner. Solid parts are imported and attached to CAD lines in MechDesigner, so we need to put a CAD line into the ground part. The CAD line will map to the x-axis of a user-defined coordinate system in Solidworks. In Solidworks, define the coordinate system XY axis center on the top pin joint center, as this is where I located the CAD line, and make sure the x-axis of the coordinate system is aligned with the CAD line. Now we are ready to import the frame into MechDesigner. Double-click on the CAD line and select the Solidworks tab. First read in the file name of the currently active document in Solidworks. This must be the one you want to import. Make sure the correct configuration and coordinate system are selected and press the import button. Now we repeat for the other moving solids, which are the important ones, as they will determine the dynamics and gravity loading on the drives. I will show the other part imports in an accelerated fashion to reinforce the technique that I showed you before. So again, align a plane to the assembly front plane. Define the coordinate system using a sketch on this plane. Remember, the x-axis of this coordinate system will align with the CAD line on the part you want to import to into MechDesigner. Now import the part into MechDesigner. We can use this part twice. For the lower part, I add another CAD line drawn from left to right, as the CAD line origin lies on the grounded joint. All the solid parts have been imported along with the mass properties. I will add a 1 kilogram load at the end of our coupler link to represent a component that is to be manipulated by the robot. So, after I have configured the power configuration and got the motors on the right joint, turned on forces and set the size of the force arrows, we can observe the forces at the joints and look at the motor forces and torques. One observation is that the forces seem to grow in magnitude as the robot tries to drive the load around the blend curve. Perhaps we can trade off between the length of the curve and the maximum curvature. I'm going to leave it there. The final video on robots will cover the selection of motors, gearboxes and ball screws.